Hello class, welcome to lesson 4 of the stage 4, which is the following: solution to quadratic equations by the method of completing the perfect square trinomial. And for short, I will be saying PST. Whenever I make reference to this whole phrase, perfect square trinomial, I'm gonna say just PST because this is way too much, way too many words. Okay, this method is also sometimes called completing the square. So when you read completing the square instead of all of this phrase completing the perfect square trinomial, it's the same. It's exactly the same. Okay, so let's start. Uh, let's pay attention to this part in here. What have I written? The following: quadratic equations that we know how to solve already. I have taught you two different types of equations, quadratic equations, and that we can already solve. For example, this one. Look at this quadratic equation. And I can solve this equation, and you too, because you can do the following. Let's bring this term to the other side so that my equation looks like this now. This form of a quadratic equation is called the standard form. Okay, just so that you know. Standard form. And what does that mean, standard form? Well, it means having the quadratic equation with a 0 on the right side. Okay, well, it can be also on the left side. It can also be written like this, right? Because it's actually the same. This and this is the same, although for, I don't know, for habit or for some customary purposes, we usually write it in this way. So the standard form means having the quadratic equation with a 0 on one of its sides, usually the right side, and the other side contains the equation, well, the expression, the quadratic expression in this way: quadratic term, and then the linear term, and then the constant term. When you have it like this, we call this the standard form of the quadratic equation. It has to look like this exactly. Let's suppose you have this. I'm gonna deviate a little from my main explanation. Let's suppose you have something like this. Okay? Is this a quadratic equation? Yes, because you can observe the square on the x right here. So this is in fact a quadratic equation. Is it in standard form? No. No, because the left side, which is all of this, doesn't have this same shape. Okay? But I can make it look in a standard form very easily. All I need to do is multiply this minus 2 times this parenthesis. And now this is in standard form because I have the quadratic term and then the linear term and then the constant term equals to 0. You see, it has to have this same shape. Okay, so now you know what the standard form of the quadratic equation is. Okay, and now how can we solve this equation? It's very simply, right? I have taught you so far this method, the method of factorization. This trinomial can be factorized. Okay, if you spend some time, some seconds or 1 minute, a couple of minutes, you can find actually that the factorization will be this, right? And then you proceed doing what I told you before, which is if the product of two numbers, this number and this number, if the product of them gives 0, then you must conclude that either x minus 3 is equal to 0, or you can conclude that x plus 1 equals to 0. And then you have this equation and this equation to solve. The first equation will give you the first solution, which is 3 when you solve this equation, and the second equation will give you the second solution, which is minus 1 in this case. So okay, it's very easy to solve an equation when you can use factorization. It's pretty simple. Okay, that's one of the methods I've shown you. Now, what is the other method? Well, when we have this type of equation that we saw in the last class, what you can do is simply take the square root. Once you have it, and again, I need to first put this into this form in order to take the square root. I'm going to write the binomial to the square equals the constant term, the other number, okay, like so. And then we take the square root on both sides of the equation. Remember the plus and minus on one of the sides. Don't write the plus and minus here, only on one side. And then continue with the equation, right? The square root eliminates the square. So we have x minus 1 equals plus minus the square root of 3. And then we have x equals plus minus the square root of 3 plus 1 after I isolate x. And this counts as two solutions, right? One solution, let me write it in blue. One of the solutions will be taking into account the plus. So it's going to be the square root of 3 plus 1. This is one of my solutions. And the other solution will be taking into account the minus. So minus the square root of 3 plus 1. These are my two solutions, and I'm done. Okay, so far, so good. Now, what's going to happen when I give you this sort of equation? Look at this equation. X squared plus 2x minus 5 equals 0. Okay, I want you to pause the video for about 1 or 2 minutes at most and try to apply the factor. We know that this doesn't look like this, right? I mean, that's for sure. So we cannot take the square root as we did here for this particular equation. But you may think, okay, maybe I can factorize this trinomial like we did in here. Okay, pause the video 1 or 2 minutes. Try to factorize. Go ahead. Okay, so by now you must be aware, or you must have realized, that this cannot be factorized. So how are we going to solve this equation? We cannot use factorization. We cannot use this other method of taking a square root like so. And so we need another type of method to solve this more complex type of quadratic equation. And that method will be the method of completing the perfect square trinomial, or sometimes known as completing the square. And let's do that method. By the way, this method is quite complex. I need to tell you these things before we go over that method. This method involves a series of steps, several steps. You have to train a lot. You have to do a lot of exercises in order to get them memorized, because it's about 4 or 5 steps. Okay, so you're not gonna memorize them at the first time you see it. It's no problem. You can practice over maybe a couple of days or 3 days, and I assure you that you will understand how it works. And the other very important thing I need to tell you is this. I'm just gonna explain to you the mechanics of how this method works. Okay, I'm gonna tell you, do this first step, do a second step, do a third step, etc. And at the end, you will get the solution. Okay, I'm gonna give you a series of steps. It's kind of like an algorithm, okay, or a process or a recipe. But I'm not going to explain to you why this method works, okay? Most of these steps will look like magic, and you're gonna have a lot of questions about why am I telling you to perform these steps. That is perfectly understandable. Just be aware that I'm only explaining the mechanics, okay? And in second semester, I will explain to you why this method works, okay? So now in this semester, you will learn how to do it. You will learn the how, and in the second semester, you will learn the why it works. Okay, guys, so let me pause the video briefly, and we can continue in a moment. Okay, so we have in here 4 quadratic equations, and we're gonna solve them by the method of completing the perfect square trinomial. Okay, so how do we do this? Let's first go over the first one. The first thing you have to do is this, guys. You have to make sure that the equation is in standard form. Okay, remember, it's gotta look like this with a 0 on the right side, and then the quadratic term, the linear term, and the constant term in that order. Okay, it's gotta look like this, exactly like this. So is this in standard form? Yes. So I just, I don't do anything. That is the first step, and it's completed. Okay, next, you're gonna make sure that the coefficient of the x squared, this coefficient, is 1. Okay, you want to make sure of that. Is this 1? Yes. So again, we don't do anything to the equation. We're starting very easy. Okay, so first make sure it's in standard form. It checks. Next, make sure that the coefficient of the x squared is 1. It checks. Okay, let's continue. And I told you there are going to be several steps. You need to practice a lot in order to memorize all of these steps. I could write them down, like as a recipe, but that's not the idea. Okay, next, what we're gonna do is this. You're gonna take the constant term, which in this case is -5, and you're gonna put it in the other side. Okay, like so. Okay, you're gonna bring it to the other side. And we know that in order to do that, in this case, we have to add 5 in both sides, and we're gonna end up with this. Okay, that's the next step, bringing the constant term so that it's alone on the right side. That's the third step. Fourth step, this is a tricky part. This is where most people get confused a little. Okay, at the fourth step, what you need to do is single out the coefficient of the linear term. Okay, this is your coefficient x. I'm sorry, it's 4. The coefficient of the linear term is 4. And what you're gonna do is this. Try to bring it some other place, like, I don't know, in a corner of your notebook, or in another piece of paper or something. Try to do that. You can do it in here, but this is a good suggestion that I'm gonna give you. Try to isolate it, put it somewhere else, and then you're gonna do a series of transformations on this number. The first transformation is you're gonna divide it over 2. Divide 4 over 2, you're gonna get 2. Okay, and then what you're gonna do is raise this number, raise it to the square. I don't know if you're aware that this symbol is used to raise. Okay, raise to the square. So 2 raised to the square will give me 2 to the square, like so. And you're gonna notice that I'm not gonna perform the operation. I'm just gonna express it like this. Instead of writing 4, because 2 to the 2 is 4, I'm gonna leave it expressed in this way. You're gonna see why in a moment. Okay, and that's the whole process you want to do on this number 4. You are gonna end up with this. Okay, this is my end result. And then that end result, which is 2 to the 2, what I'm gonna do is I'm gonna bring it back to my equation. Okay, I'm gonna go back to my equation, which is this at this point, and I'm gonna add this number 2 to the 2 to both sides of the equation, like this. Look, 2 to the 2 equals 5 plus 2 to the 2. That's the fourth step. Okay, remember, if you add this number to the left side, you must add it to the right side, because we're talking about an equation, and it needs to be balanced. Okay, then what? Okay, this is another tricky step. At this point, guys, you are gonna write all of this trinomial, okay, all of this trinomial as a binomial to the square. When you do this method of doing this transformation to this number and you arrive at this, when you add it to this to these two terms, when you add x squared plus 4x plus 2 to the 2, what this is going to become is a perfect square trinomial. And if you remember, a perfect square trinomial can be written as a binomial to the square. In this case, that binomial will be x plus 2 to the square. okay? And at this moment, again, I want you to pause the video momentarily, okay? And I want you to make sure that in fact, this binomial to the square gives you this trinomial. When you expand this binomial to the square, you're gonna get this trinomial. Make sure of that. Go back, go pause the video and do it. Okay, now you're back and you must have realized what I told you. Okay, now how are you gonna write this binomial? How? It's very simple. All you need to do is look at the first term, which is x squared, and the x is gonna be here, okay, like that. And the other term in the binomial will be actually this number, okay, this one. You're gonna put it there. And what sign are you gonna place? Is it gonna be plus or minus? It's gonna be the sign of the linear term, this one, okay. And then you raise that to the square, and that's it. That's it. That's why I told you to keep this number expressed as 2 to the square, okay, so that you know what number, which in this case is 2, which number, which in this case is 2, and that's going to be here. Okay, on the other side, you can actually perform the addition. That's going to be 5 plus 4, because this is 4, and you're going to get 9. Okay, and after all of this stuff that I know must be a little complex to you if you haven't seen this process before, now look at this equation now, guys. Does this remind you of something? We have already solved this type of equation. When you have a binomial to the square equals another number, you can solve this very easily by just taking the square root on both sides. Okay, the square root of this left side equals plus and minus the square root of 9. The square root takes away the square, so we get x plus 2. And we have plus and minus the square root of 9, which is 3. So we have plus and minus 3. And finally, we get two equations to solve, which is x plus 2 equals 3 positive, or x plus 2 equals minus 3. And so I'm gonna get my final two solutions, which is 1. After I isolate my x in this equation, I get 1. And after I isolate the x in this other equation, I get minus 5. There you go. So these are my two solutions to this particular equation. Now, some of you must be saying, okay, but I can solve, I don't know if you, some of you realized that this equation can actually be solved through factorization. And yes, you can solve it through factorization. But sometimes that's not going to be possible, and you need to use this other method. Okay, so I'm teaching you this method. Even though you can solve it by factorization, I need you to understand how this method works. Is it complex? Yes, it involves many steps, but once you do it 5, 6, 7 times, you will know that it becomes second nature, and it's actually not that difficult. Okay, maybe I'm realizing that I'm just gonna show you two of them, two equations, because doing 4 at a single lesson, I don't think that's a good idea. So let's only solve the second one, and that's it for today. We're gonna solve the other two in the next lesson. So next, this other equation. One more time. Listen. First step, make sure that the equation is in standard form. So, okay, I'm gonna do that first. Okay, you see, I have rearranged all the terms. I have bring these two terms to the left side in its proper way, so that now this equation looks in standard form. Done. That is the first step. Second step, I need to make sure that the coefficient of the x squared is 1. Is it 1? No. No, it's not. It's 2. So how do I fix that? Well, I can fix that very easily. I can divide both sides of the equation, both sides over that same coefficient, over 2. Okay? All of this side over 2, as you can see, and this side, which is 0, over 2. And you're going to see what happens if I do that. If you remember, when you have a polynomial divided by a single monomial, what you do is basically divide each of these terms over 2. So 2x squared over 2, you get x squared, plus 8x over 2, you get 4x, and minus 1 over 2, you get minus 1 half. Do not write decimals. Leave it like this. And on the other side, you get 0 over 2, which is 0. So you see, now I have made sure that my equation is having a coefficient of 1 on the x squared term. You see, this equation, guys, is the same as this equation. They are completely equivalent. So now I can start doing the third step. The second step is completed at this point. So what is the third step now? Third step, take the constant term and bring it to the other side. There you go. Third step completed. Fourth step, single out the coefficient of the linear term, which in this case is 4. Okay. Bring out, it's gonna be the same in here that in here. Okay. Bring it over here to a separate location and transform it. Divide it over 2. You're gonna get 2, and then this, raise it to the square. So you're gonna get 2 squared and leave it expressed like this. Okay, once you're done with that, go back to your equation and you're gonna add this number to both sides of this equation at this point. So let's do that. X squared plus 4x plus 2 to the 2 equals 1 half plus 2 to the 2. That is my fourth step. Okay, next step. When I have done so, when I have added this particular number to both sides of my equation, this trinomial will be actually a perfect square trinomial, and that means that I can write this as a binomial to the square. A binomial to the square. What's going to be my first term in here? Is going to be this x. What's going to be the second number in here? It's going to be this one, 2. And what's going to be the sign, either plus or minus? Well, it's going to be the same as the sign of the linear term. There you go. So as you can see, it was the same as in the previous case. And on the other side, you can actually perform this whole operation. 1 half plus 4, you're gonna get 9 over 2. Make sure about that, okay? Make sure that this is 9 over 2, and you will know that it is. Okay, and at this point, everything now is a piece of cake, okay? Because all you need to do now is take the square root in both sides, which we have done already. X plus 2 to the square. Let's take the square root of that, and let's take the square root of 9 over 2, 9 halves. Okay, remember the plus and minus. Let me erase this because I don't need it anymore, so I don't want this to be bothering me. And finally, remember the square root takes away the square, so we end up with x plus 2 equals plus minus the square root of 9 halves. Leave it expressed because we cannot calculate easily the square root of this number, so just leave it like this. Remember, just leave it like that. And finally, what you end up with is two equations that you have to solve, which is x plus 2 equals the positive root of this number, or x plus 2 equals the negative root of 9 over 2. And finally, isolate x. X will be the square root of 9 over 2 minus 2. That is one of my solutions. I know it looks complex, but it isn't. Or the other, let me write a vertical line, or the other possibility will be x equals minus the square root of 9 over 2 minus 2. And these are my two solutions for my quadratic equation, this one and this one. Okay, so these are my two solutions to this particular quadratic equation. And now you can see that for this particular equation, you cannot use factorization. Okay, try to solve this by factorization and you will fail. Okay, so these are my two solutions obtained through the process of completing the square, also known as completing the perfect square trinomial. I know it's a lot of steps. You have to maybe rewatch this one of these 2 or 3 times until you get it down. Okay. Tomorrow we're gonna practice with these other two, and I suppose that by now you're gonna have memorized all the steps. Okay, let's stop right here, guys.